Hello my friends and welcome back. Today we will be talking about the 2D to 3D conversion. So how do we represent on a 2D scatter chart a 3D object? For this I open a new spreadsheet. So let's go to the blog here, excelunusual.com, and type say 3D. And 3D is a little bit it will give you a lot of results. This is the tutorial we are looking for. I would rather say 2D 3D or 3D conversion, and there are several. This is okay, but this is the optimal. I mean, I derived these formulas here first time, so we go to PDF, and essentially I explain why the perspective looks the way it looks. From closer it looks wider. As you look farther and farther, this road that has a constant width, it looks narrower and narrower. And then I explain how having a window, you see this is a window, and look outside the window, there's a 3D system of coordinates with a point P, and you can do so-called ray tracing and convert these XYZ coordinates of this point P in the system, in this three-dimensional system of coordinates, into a two-dimensional system of coordinates, UV, on the screen. And a good analogy is if you have a little gun, an imaginary gun, and shoot from your eye to a certain point in the scene, the little bullet will, the imaginary bullet, this is not a real bullet, will form a hole, and these XYZ coordinates will turn into a UV. So three coordinates go into two coordinates, UV. And in order to derive them, I decompose the problem into two easier problems. Namely, I took a horizontal plane, so a horizontal flat surface passing through the origin of the both systems of coordinates, and a vertical plane passing through the origins of both systems of coordinates, and simplify the problems. And you get this formula for the horizontal, and for the vertical you get this formula, and these are the two formulas which I pasted here. So for this I'm going to show you first how to, I'm going to give you an idea what I did here. So let's say we have the eye here, okay? So this is the eye. And we look straight forward through a window right here. So this is a window, okay? And in the middle of the window there's a point, let's call it S from screen. So let's call this rather screen. And outside the window, so this is in the house, we are in the house and look through a window. This is equivalent to us looking at a computer screen, but we are looking at a 3D object. So we have a system of coordinates right here, outside the window, X, Y, and Z, and the origin is called O, and we have a point here, P from point, and we need to figure out how to transform the X, y coordinates into, no, I'm sorry, the xyz coordinates into u, v on the screen. So these are real life coordinates and these are screen coordinates. Okay, so let's call this object E from I. This we'll call this S from screen, the origin of the UV system of coordinates, UV, and O, the origin of the 3D system of coordinates. And this point P will have the coordinates x, y, z. Okay, so if we drop a vertical here, another one here, another one here, and essentially we build like a cube, like a little. So there's a parallelepiped with a, this is y, this is x, and this is z. I always put xy flat, okay, horizontal, because z to me means height, so altitude, z. So actually, to better describe the phenomenon, I like to say take x, y, z, the I to screen, so ES, distance, the screen to origin, SO, and that's it. Turn it into a U, V, okay, coordinates. And for this is very easy to decompose the problem into two easier problems. We can take a flat, let's choose blue here. So we decompose the problem in two problems, much easier problem. Take a flat surface, horizontal surface, so flat plane here. And so this is horizontal plane, and a vertical plane, okay, red, okay. I'm sorry, let me see, a vertical plane. So this is a vertical plane, and let's now focus on the horizontal plane. Go to the next page, and we have here the I, okay, so E. We have a ray going straight ahead, and the screen will produce a segment on this horizontal plane called, and here is a axis of coordinate U. Here we have, let's say this is S screen, O here, okay. So this is Y, this is X, and we have the point right here, P, okay. So this is X and this is Y. Let's call these points, so this is E, S, so this is a ray, a straight ray, or the bullet piercing the window right here, okay. So S, let's call this A, this P, let's call this B, okay. So right from the start we see several triangles here. We have this large triangle, B, P, okay, E, and this is 90 degree. Okay, I didn't draw it perfectly, but this is 90 degrees. So pi over 2. And here we have S, A, and we are looking for, let's call this horizontal. Projection. Okay. So we have here triangle similarity. Okay. Triangle similarity. Okay. And this triangle ES, so triangle ESA, okay, so this guy is similar, I don't know how to say, but let's say similar, similar with triangle EBP, okay, so with this triangle, the big one. And if you can check this searches on YouTube, on on Google, and figure out. It's very simple, but this is, we will always use this, so this is very important. Triangle similarity, when two triangles have the same angles, all three angles are the same, which means they are similar. This is one of the criteria. There are other criteria, but this is what we use here. So the angle right here, E, is common for both triangles. This is 90 degrees in both, so ESA and EBP, these angles are 90 degree here. And since the sum of angles in a triangle is equal to P, or 180 degrees, it means this other angle right here is equal to the other angle. So there is perfect triangle similarity. In similar triangles, we can write the following proportion: ES divided by SA is equal to, so ES, SA, EB, B divided by BP. Okay, so who is ES? ES is eye to screen. Okay, so let's rewrite this. So eye to screen ES divided by, who is SA? SA is the U coordinate. Okay, so this point has XYZ coordinates, and the projection on the screen is U. Okay, so is equal to, who is EB? EB is ES plus, so I screen to object, screen to origin, plus SO, plus what? Plus Y, and divided by, who is BP? BP is just the X coordinate of the point P in the three-dimensional space. So from here we can say the product of this guy and this guy is equal to the product of this guy and this guy. This is basic algebra. So U is equal to, this is elementary, so we go U is equal to ES times X divided by ES plus SO plus Y. And again, we will use this for a roller coaster. Okay, so just bear with me, be patient. We will get a roller coaster out of this. Not today, but we will get closer today. So we have this for the, if we look here, I decomposed it into a horizontal plane and vertical plane. The vertical plane is red, so I'm gonna go to the next page here. and this is the eye. Okay, so eyelashes here, so E, point E. We look at the screen here. This is a screen here, and what do we have here? We have the axis V. Okay, this is, let me see, this is not, I don't like that it's not perpendicular. Let me make it perpendicular, so that's about right. So here V S screen, so the origin of UV system of coordinate is S, and if we intersect it with a vertical plane, we get the V coordinate here, and the 3D system of coordinates is right here. This is Z, axis Z, axis Y, and axis X is right here, goes perpendicular on the sheet, so you don't see it. It is not in this calculation. The point is right here, P, and we do the trick with a bullet. The bullet makes a hole here, right here. So let's call this I'm a P prime. Let me see, in the previous we called it A. Let's just give some different names so we are not confused. Control, I delete this. So P, point P, let's call this A, B, C, let's call this D, okay, D, and call this so this is P of X, Y, Z, but X is 0 in this vertical plane, so this is a vertical plane right here, okay. Sorry, so this is all a projection on the vertical plane here. So this is ES, eye to screen, screen to origin, SO, and what is this? Is Y, okay. So this, the length of this is Y, the Y coordinate of point P, and what is this? SD is V, okay. So we can write the following. Again, we have two similar triangles, so triangle ESD is similar, so sim, with triangle let's call this F, similar with triangle EFB, okay. So from here we can write the following relationship: ES over SD, D is equal to EF divided by FP, okay. Why? Because this triangle, okay, and the large triangle, okay, they are similar. They have the same measure angles, the same angles. Angle E is common here, then this one is 90 degrees here, this is 90 degrees here, and since the sum of all the angles in a triangle is 180 degrees, which means this angle is equal to this angle. So we can write this proportionality relationship. So who is ES? ES is eye to screen. So ES divided by SD. Who is SD? SD is coordinate V, is equal to EF. Who is EF? Is I to screen plus screen to origin, SO, plus what? Y here. OF, which is Y. And who is FP? FP is the Z coordinate, okay? So Z, here it is. Z. So Z. And we can rearrange this relationship. V is equal to ES times Z divided by ES plus SO plus Y. And if we look at the previous page right here, we have a similar relationship right here. And if we go to, we don't need this anymore, let's just close it. We have the relationships right here. So let's try to implement a cube in 3 dimensions. And in order to implement a cube, let's look what we need to adjust. So we can put some parameters. Let's right here, let's call this, let me see, ES. So ES. I don't know why I cannot see you. Let me see. Maybe it's white. Oh yeah, I can see it now. So let's center this. So ES. Let's call this SO. So screen to object. What else we need? We need let's use a scale factor. So scale ES, let's put ES for now 10, 5, 5, 5, and scale 1, and let's build our, let's add rotation. Okay, so rotation around the z-axis, so z rotation, z-rot. Let's put it to 0. Let's set it to 0 and center everything. We go to developer, insert, let me see, insert, we are looking for this guy here. It's just slow, it doesn't react right. Okay, it reacted finally. So actually ES and SO, let's leave them unadjustable. We can just type in values. Let's change the scale properties. Let's call it scaling. Why? Because scale might be a reserved word. So let's say minimum is 0, maximum is say 10. Okay, scaling, and double click on this. We got sub here. Let's say scaling. I believe this is what, B8. So you know what, I don't like something. Let's just It's a lot of wasted space, so let's put them here. Okay. So B5 in square brackets. So B5 is equal to scaling divided by 10. Normally we should put value divided by 10, but it will work just fine without value. Okay. And also Z0, let's increment let's change the angle in increments of 10. There's 360 degrees in a circle, so Z0 needs to go from let's say copy this and paste it. Properties, so Z0. So we need to go from 0 to 36, actually to 35, because 360 degrees is equal to 0 degrees, is the same thing. So we go in increments of 10, so Z0, we double click on it, we get this, and let's say B7, so B7 in square brackets, 7 is equal to 0 times 10. Okay, we can put 0 dot value, but is not necessary. It's not absolutely necessary. It's a good practice to put value. Sometimes you have formulas. The default is value. That's why I never put it myself. Make it as simple to read the code as possible. So 0 rot times 10. Let's get out of design mode from here and test them. So you see there's something here. Go back in design mode. This doesn't work. Properties, so scaling, this is 0 to 35, okay, and so B5, B7, 0 scaling. It should work, I don't know why. Oh, it does work. So it goes from, in increments of 10, from 0 to 350. In order to provide rollover features, let's we talked about this in the previous tutorial, I believe, or 2 tutorials ago. Properties, we go from -1 to 36, and here if 0 is greater than 35, then 0 is equal to 0. So once okay, then, and let's do some indentation here. So if 0, Control C, if paste it here. Actually, let me see. Control V. If 0 is smaller than 0, then 0 should be 35. Should go to 35. So this will allow us to change the angle only clicking on a single arrow. If we are maybe sometime lazy, we just want to click continuously on a single arrow, is a good feature. Check this out. Now get out of design mode. 240, then we go to 350, and now 0. You see, it goes up, 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 then it rolls over, goes to 0. Here it goes down, down, down. Once it goes to 0, then goes to 350. So the scale also, let me see, the scale, there's a problem here. Let me see, go back in design mode, properties. Maybe the name, I don't know, name, I don't think is a problem. So minimum is 10, maximum is minimum 0, maximum is 10. Let's make maximum 20. Scaling. Just call this different name. Maybe scaling is some sort of a reserved word. So scale object. So underscore obj. Okay, scale obj. Control C. So copy that name and go here and paste it here. Let's check out if it runs. Huh. Oh. So scale object. You know what? Let's go back and delete this. Maybe there's some corrupt or something. Control C, Control V, properties. This is called what? Scale object, and goes from 0 to 20. Okay, scale object, and here, let me see, scale object. That looks good. Get out of design mode. Okay, now it runs. It seems there was some kind of corruption with that button. So now it works. So let's call this X, Y, and Z. And I clicked here, and let's center all the worksheet, all the worksheets, center it right here. Okay, oh. So X, Y, Z. So first we're gonna turn this into an XYZ, X, Y, Z, which is rotated. And let's add a translation, okay? So we go here to developer and design mode. Let me see. Control C. Let's translate it along the x-axis. So property. Let's call this dx, so delta x, dx, and translate it from minus, let's say, 5 to plus 5. Okay. Double click. So dx in cell B9. So B9 in square brackets is equal to dx That's it. And I like to put them in order. Okay, that's okay. So let's see if it runs. We need to get out of design mode. Okay, so it goes from -5 to +5. So I need to show you something here. Let's pick up a black. So I want to build a cube, okay? Let's build a cube like this. Point A, B, C, D, sorry, let me, D, and then go back to A, okay? So I draw some arrows. So we go from A to B to C to D and then to A, and then go up, okay, to a point, let me see, A, B, C, D, E, and then right here to point F, okay, then to a point G, and to a point H, and then back to E, okay? So that's how we do it. So A, after A we go to E, F, G, H, and E again. We go back, we return, and then we need to connect this. So BF, BF, what else? CG, CG, and what else? DH. So DH. Okay. So let me see how we do this. We need to move this to the right. So A, B, C, D, A again, and then let me see. So A, B, C, D, A, E, F, G, H, E. So E, F, G, H, E, and then we need to leave a space. Okay, otherwise we get artifacts, as we saw in the previous tutorials. We need to do BF, CG, and DH. So BF, okay, I'm sorry, B, F, C, G, and then D, I believe F, let me see, DH, okay. So XY, let's put here -2, 2, okay. So -2, let me see. A, it must be -2 + 2, then B -2 -2. Okay, so essentially what we do here, so this is axis Y, this is O, this is axis X, and this is axis Z. Okay, so A will be what? If we plot just the base plane here, right here, X, O, Y, A is point here, -2, and here 2. So -2, 2. So this is point A, and then we go to point B, which is -2, -2. Then we go to point C, which is 2, -2. Then we go to point D, okay, which is 2 plus 2 plus 2, and then we go back to point A again. So A is -2, 2, okay, and all of these 4 points have the coordinates Z is equal to -2, okay, so is the bottom. So Z right here, -2. So let's go and try to see this right here. So -2 plus 2, and then we go to -2, 2, then we go to 2 -2, let me see, x 2 -2. Okay, so -2, 2, -2, -2, -2, 2, -2, -2. I cannot see, I don't have enough light. -2, -2, then you go to 2, -2, then you go to 2 -2, then you go to 2, 2, and then you go back to A, which is -2, 2. Okay, so we can copy this, okay, Control C, and we can just paste it here, because it's essentially the same thing. There is a bottom square and a top square. See, XY coordinates are the same for these two squares, just the Z is different. So for the Z, let's go here, and for the Z we say this is -2 for all these 4 points, so 5 entries, and here 2 for the rest. Then B, this is equal to this guy, okay, B is the same point, copy here. F, this is equal to F right here. Then this is equal to C right here, and this is equal to G, this is equal to D right here, this is equal to H right here. Okay, so for now I would suggest let's not insert any rotation, any translation, anything, any scaling. We do that, we finish this in the finish that in the next tutorial. Right now let's just plot UV coordinates, create this 2D to 3D to 2D conversion. So U and V, okay, V. So who is U? X, so U is equal to equal to x, which is right here, times ES right here, ES. Let's hit F4 and make ES absolute. Hit return, go back, divide this by, I hit return so I don't lose it, okay? If it's a long formula, occasionally I make it permanent so I don't lose the thing if something happens. So divide it by a big parenthesis here, ES, which is this guy right here. I'm sorry, not that guy, is the ES right here. Absolute reference, so F4 plus SO, again F4, so absolute reference, plus Y, okay, Y. And I like to make the column here, the column absolute, so $sign in front of column. Here B4, let's make this $sign here. No, I'm sorry. 15. That's okay. So this is the right formula now. Let's now copy this right here, okay? And we need to change something. Instead of Y, I need to put this as a Z, okay? So Z, so D15, okay, so this is a formula, V. So D15, okay, this looks right. So let's just copy this down, delete right here. So actually let's leave it so I show you how to get rid of these artifacts. And insert a chart, scatter chart. Let's use this is good. Okay, let's get rid of some artifact. This is already a 3D representation of the of our cube. So let's delete here, this one, delete right here, delete. So we have a three-dimensional cube. Let's go closer to the eye to screen. Let's make it smaller so the cube appears large, smaller. 4. Okay. 4, and screen to object. Let's send the object farther so it's not so big. So let's say 6. And another thing I would like, so you believe me that this is a 3D object, let's do a rotation, okay? So what's the formula for rotation? Formulas for rotation are here. I'm gonna write them down. We will rotate this cube around the z-axis. So z-axis will stay the same. The z will stay the same. So z, this is equal to so when we rotate around a certain axis, that axis, that coordinate remains the same. Copy here. Okay. We need to, of course, delete this stuff. For x and y, I'm going to show you here. So if we rotate, x prime is equal to x times cos of theta, okay, and plus, you can go back to the previous tutorial or just Google how to derive these formulas. Plus y times sine of theta. Of course, theta has to be in radians. So y prime is equal to y cos of theta minus x sine of theta. Okay. So these are the formulas for rotation. So I'm going to go here and say this is equal to x is equal to the previous x right here times cos of radians. You can see the previous the previous tutorial. The angle, we take the angle from where? From here. Okay, plus the y times sine of radians of the angle right here. And of course the angles have to be absolutely referenced. So F4, heat return. There's a problem. Okay, give me a second. I think it added a parenthesis, so we will figure out if there's an error. We will see it in the image, and let's copy this here, right here. So what is this? Let's put this back. So y is equal to plus, here is a cos. Okay, so you can go here and check. You see the for y, the sine becomes a cos, the cos becomes a sine, sinus, and then a minus at the beginning here also. So here is a sine, and there's a minus here in the front. There's a plus, cos, that looks good. Okay, and delete these. And the data, this is okay, but let's pick up the data from the rotated cube. Okay. Same here. Pick up the arguments for the UV functions from the rotated cube. Right here, copy this. Okay, Control C, Control V, Control V, Control V. Okay, so as you can see, I'm gonna rotate this, and the only problem I have is the scale. Format axis, let's put a fix. So this is auto scale, so it's changing, so that's why you don't see it right. So minimum, let's make it -2, maximum 2. Okay, let's do the same here. So -2 and 2, and here we have it, the rotating cube. Okay, a three-dimensional object. This is your first three-dimensional object, and this being said, the file will be in the description, and save this. Oh, actually, no. You need to make sure you save it. Oh boy, save as. I'm gonna save it after I close. Let me go back. So this very soon will be turned into a roller coaster. You have all the elements. You have the control macros, you have the conversions, translation, rotation, scaling, and then you have the 3D to 2D conversion. And this being said, I will see you in the next tutorial. Thanks for watching.